The Technological University of Delft is an institute embodying innovation and technological progress. Towering high above its campus is the EWI, the Clocktower of the TU Delft. With its height, it's visually dominating the TU Delft campus. However impressive its 21 floors may seem at first glance, the tower has to deal with quite a few problems. These problems have a negative effect on the comfort and energy consumption of the building. To understand these problems, one must first understand how the building works. Because the detailing of the facade adheres to the standards of 1969, the building has a lot of thermal leaks. Thermal conductive materials that transport cold from the outside directly to the inside, creating very cold surfaces and water condensation as a result. The EWI building has a double facade, which works as a buffer by means of an air cavity. In the summer, the double facade is actively ventilated, and in the winter, the double facade is closed off. The sun shading that is integrated into this facade keeps the warmth from entering the building, but they give little room for adjustment of these conditions. Unfortunately, the heat trapped in the facade in the summer is poorly ventilated. The warmth then infiltrates the building, creating a bigger need for cooling and an uncomfortably warm window. This doesn't help in establishing a comfortable climate, nor in reducing the energy expenditure to maintain it. This takes us to the air-based heating system. Either hot or cool air enters the rooms through a convection cabinet next to the double facade. It then continues via vents near the floor to the central hallway, where it is sucked out of the building. Simply leaving the door to your office open imbalances the entire system. The building itself has a long axis in a northwest direction, with a long facade aimed at the southwest, catching not only a lot of sunlight, but also a lot of wind. Because the building is relatively high in comparison to the surrounding buildings, this wind creates hard thrusts on the ground level. The poor implementation of the double facade is the main defect of the building. A different project, for example Clocktower in Düsseldorf, has a more active role for the double facade, where it is used to regulate the ventilation. It isn't just a buffer, it's a space in which outside air can heat up and eventually be used to ventilate the room in wintertime. In summertime, the air leaves the building through this double facade, effectually inverting the air streams. The Teacher Training Center in Chur is another example of a project that works with the conditions on the site. It shares the orientation with EWI, using the relative warmth of the sunny side and that of the coolness of the shaded side to create a natural airflow in the building. Furthermore, the sun shading keeps the warmth outside in summer, but actually harvests it in winter. If EWI would be designed today, it would be conform our current standards. No thermal leaks would even be allowed. And the double facade in particular would form an opportunity to create a reactive system that works in conjunction with the climate system and the construction. The EWI would then be a true representative of the Technological University of Delft.